All right, let's take a look at 6.2 here. It's about simple and compound interest. So let's first look at simple interest. Basically, all you're doing is you're taking this principal amount, which means however much you're investing or however much you have in your bank account, and what you're getting is a percent of that every year added onto it. So what we're going to take a look at is, it's pretty straightforward. The first couple you can look through those examples, but let's just jump straight to build your skills section. So the formula here is your interest is equal to your principal, how much you have, with the rate. You got to change this to a decimal, so it's moving it 2 spots. So you'll notice that 2.5% becomes 0.025. And then what you do is then you have to change it by the time. So if it's 1 year, which in this case it is, times by 1. If you look at this one, it's in 2 years, so what's happening is you're getting that interest twice, so that's why you're multiplying it by 2. So you go through, it's 1,000 times 0.025 times 1, and it's 25, which means you're going to get $25 extra on your principal that you put in, or if it's a loan, you're going to have to pay that $25 extra. Okay, same thing with B, 1,000, again, 5% is not 0.5, right? 0.5 would be 50%. So 5% is 0.05, right? Moving it 2 spots. Or divide your percent by 100, because that's what it's out of, right? A percent is always out of 100. Okay. Third one there, I times by 2 because it's 2 years. We take a look going further. Fourth one, same idea. B, you've got 0.025 times 2,000 times 1. And they're asking here, when you move on, it says what happens to the amount of interest earned when the principal and the term stay the same, but the rate doubled? Well, if you're doubling the rate, your interest doubles. Same thing is if you, what happens to the amount of interest earned if the principal and the rate stay the same, but the term, so instead of 1 year, it's 2 years. Well, what happens is it's going to double as well, because instead of just collecting that interest once, you're going to collect it twice. Okay. Typical questions you're going to get. What's the investment of $600 after 5 years with that rate? So what's happening is there's your principal, 600. Change your percent to a decimal right there, and then how long you're going to do that? 5 years. Since it's happening every year, you're going to get 5 years of that. So you multiply it out and you get $112. Same thing here. Notice I times by 10 because it's over 10 years. So it's pretty straightforward. You're just basically taking a percentage, and then the only difference here from before is sometimes it's over 5 years, sometimes it's over 10 years, sometimes it's 2 years, and you have to multiply by how many years that is. Okay. Compound interest is a little different. Compound interest is when you're collecting interest over a period of times, and sometimes it happens 4 times in a year, or sometimes it's going to happen semi-annually, which is twice in a year. And so what you do is you have to include that, and you can do this where you do simple interest and you do it a bunch of times, and there's an example of that, but it takes longer. So there's actually a formula that makes it a little easier. I started this is super important. Understand that the A in the formula is basically your final value. So it's going to include how much you started out with, plus the interest on top of that. Okay? P is, of course, the principal again. R is still...
Mr. Hanna, call 224. Mr. Hanna, 224.
Sorry about that. R is still the annual interest rate, again expressed as a decimal. And the N is the number of compound periods in a year. So this is the only new one here. We had T as time before in years. But N is, sometimes what happens is you're going to, it's going to say it's going to compound semi-annually. So if it's semi-annually, that's twice a year. If it's quarterly, that means it's happening 4 times a year. So you've got to include that in the formula. Okay? So let's jump all the way. You can go through these examples. They're good to look at, but let's take a look at what we're going to be doing here. And so it says calculate the final value, so how much you're going to have in total. If you deposit $5,000, there's your principal. 3%, you're going to change that to a decimal to 0.03. If it's compounded annually, so that means it's only happening every year, which is awesome, so you only have to divide by 1 for 2 years. So what I did is you go in 5,000, and then you're going to have 1 plus 0.03 divided by 1. What I do is when we get other numbers, I go 0.03, well, divided by 1 is just 0.03, and I add the 1 in front of it. So that's why I got the 1.03. And then for 2 years, so then that's squared. So on your calculator, you go 5,000 times 1.03 squared, and you're going to get that value. Okay? I guess what I should explain here is in compound interest, the difference is you're not just collecting the interest off. Let's go back to this one here. You're not just collecting the interest off $5,000. The first time you get 3% off the $5,000, what happens is you actually then, once you get that interest, it's being added onto the $5,000, and then now the second year, what happens is you're going to collect interest off $5,000, and well, what's 5,000? 5,000 times 0.03 is 150. So in the second year, you're not collecting interest off just the 5,000. Your money actually is at 5,150, and so you collect 3% of that, and that's why it's going to be a little bit more than 150. So that's why it ends up being 5,304. Different than simple interest, because in simple interest you would just collect 150 and 150, and you'd only end up with 5,300. Okay. Question 5 here, same idea. The first part is I did it if it's compounded annually, right, for the 3 years. So that's why I got 4,000 times the 1.035, because 3.5% is 0.035, and of course what that 1 is doing is it's adding in that $4,000 that you deserve as well, so that's why it's 1.035. And then I cube it because it's happening over 3 years, and so you end up with 4,434.87. If I just did simple interest and you only received interest off that $4,000, you're basically getting that same amount every single year. And so when I go 4,000 times 0.035 times 3, what happens is you get 420. Add it to the 4,000 that you started with, and you would end up with 4,420. So you don't get as much if it's not being compounded. When I subtract it, if you use the compound, you actually would get $14.87 more. Okay? Hopefully that makes sense. There's a good question that we do that shows how compound gets bigger and bigger over time. The next one is 8,000 at 2.5% for a term of 5 years. So because it's compounded annually, I don't have to divide my percentage by anything. By the number of terms, because it happens just once a year. So that's why it stays at 1.025. And the term, of course, is 5 years, and it's only done every year, so it's to the 5th power. And you end up with $9,051.26. So how much interest is that? Well, you started with 8,000, so 9,051.26. Take off what you started with, and that's how I got that answer. Again, if I'm moving too fast, just pause the video. Pause the video, get your information down, and then start up again. All right. Here, this is where they jump into and show you that sometimes when you're compounding interest, you do it annual means once a year. Semi-annually means, I shouldn't say 2 a year, but twice a year. Quarterly means what's happening is they're going to do it 4 times a year. And monthly, of course, how many months in a year? It's 12 times a year. Okay, so understanding those terms will help you be able to figure out the compound interest. Formula doesn't change, the numbers are going to end up changing. So this one's pretty straightforward. At 4%, that's 0.04. They're wanting you to find the final investment, so that's why you put the 1 in there, because you want to add in that 4,000. And that's what happens when you put that 1 in. So 4,000 times 1.04, and it's over 8 years to the 8. The difference here in semi-annually, what you end up doing is, the way that I do it is I attack this first, that little fraction. So I go 0.04, and I'm going to divide it by 2 because it's happening twice a year. And that ended up being 0.02, which is why this is 1.02. So it's 4,000 times 1.02, and now instead of it being to the power of 8 because it's happening in 8 years, well, if it's happening twice a year for 8 years, 2 times 8, that's what gives you your 16, because you actually compound it 16 times. Okay, and you end up with that value. Quarterly, it's the same thing. What I do is I attack that fraction first. I go 0.04 divided by 4 because it's happening 4 times in a year, and that ends up being 0.01, which is why that's 1.01. Now, how did I get that 32? Well, if you're compounding it 4 times a year for 8 years, 4 times 8 is, it ends up happening 32 times. So that's why it's to the power of 32. Monthly, when you're looking at monthly, again, do your 0.04 divided by 12, and you end up with 0.00333333. So you add a 1 to that because you want to include your total of 4,000 into your final answer, and you times by 4,000, and you take this to the 96th, because again, 12 times a year, if you do that 8 times, 12 plus 12 plus 12, or just 12 times 8 is 96. And that's how it got to the power of 96. Again, you can see this, I've got these already up, filled in. Same thing, if it's going, they want you to compare, what if you just deposited it and you only received compounded once in the year? So that's why I end up with, when you do 10,000, basically I went 10,000 times 1.375. Right? You got one chance at interest, and you basically get $375 extra. However, if you compound it on a daily basis, what ends up happening is I had to take, and what I did on my calculator is I went 1 plus, and then I did bracket 0.0375 divided by 365 because it's being done 365 times in the year. And that's, once I got that, I end up with a really tiny number. I took it to 365th because it happens 365 times. So I did it to the 365th power and times it by 10,000. And that's what I ended up with. When I subtracted them, I got a difference of 710. So for me, on my realistically, what I do is this is what I'm punching in my calculator. I wish I could show you this in class, but it's 10,000, and I go times. And what I do is, if you put a bracket and you go 1 plus 0.0375 divided by 365, enter bracket, and then on your calculator there's a button that kind of looks like that, and that means take it to a higher power, and you want to take it to the power of 365. That's how you can get it all done in one step, and you'll end up getting that answer. Okay, I'm going to finish this off real quick. It's not quick, but this is kind of a long-winded question. what it's doing here is it's trying to show you what's actually happening with that compound interest. And so it's saying you got $3,000, you invested at 3.25% a year, but it's compounded quarterly, which means 25, it means like every 4 times. So what I did is I had to take that, it's over 2 years. So what I got is you've still got 3,000 times 0.0325 times 0.25, because when we go, this is doing it with simple interest. There's my rate and my time, because it's quarterly. So that's why it's not 1 year, it's actually 0.25. It's happening 4 times a year. And you end up with $24, and I added it on. And here's the difference. What happens is now, when I get into my next quarter, I get interest off $3,024, not just $3,000. Okay? And what you can see is, I do it again, and now I get $24.57. I added on, I added this onto that, because that's what I started with, which is kind of sitting there, so you added it onto that, and you end up with this value. So guess what? My next term, my interest is actually on that term. I do the same thing, finding 3.25% on a quarter of a year, that's why it's times 0.25, and now I end up with $24.77 in interest. Well, that gets added on to what I started with, and now my value for my next term is this much. So I start with this much. And I repeat over and over again 8 times, because in 2 years, if you're doing it quarterly, that means 4 times a year, you end up with 8 opportunities to gain interest. And so, to me, this is a great example of showing you how compound interest is different than simple, because if it was simple interest, I'd receive that exact same amount of interest every single time, because it's not being added on to what I started with. Here, you're adding that on every single time. So look, my interest is constantly increasing. I'm getting more and more interest. The bigger my value starts growing, the more and more interest I get. Okay, and so that's, to me, the biggest difference between simple interest and compound interest. The last little thing here is kind of cool. It's called the Rule of 72. And basically what they say is, if you go ahead and take whatever your interest value is, if you divide it by 72, it'll show you how many years it will take to double your value. I could get in and explain why that works, but it's kind of, there's a long explanation in that. So what they're saying here is, use the Rule of 72 to estimate how long it's going to take you to double it if your interest rate is 4%. So all you got to do is take 72, divide it by 4, and it's 18 years. Well, what I did is I said, well, how is that possible? So I tried it. I said 6,000 times 1.04, because that's annually, and I took the power of 18, and it did. It worked out to 12,000. You're just over double it, right? So the idea here is, whatever your percentage is, take 72 and divide it by your percentage, and you'll figure out roughly how many years it takes for you to end up with double the amount. Okay. To work backwards, let's just a quick look at 11. What I did is I was trying to figure out here with algebra, if I would go 72 and I would divide it by my percentage, it would give me how many years. Well, here now they give me the years, so that's why I said, oh, that's got to equal 15. And then using algebra, I times everything by x. Now 15x is equal to 72, so then I divide it by 15. So to go backwards, do the same thing. Take 72 and divide it by how many years they tell you it's going to take to double it. And that's going to give you the percentage that you are at. Okay, that's really quick. Simple and compound interest. I might actually throw in another assignment on this, because I think it's super important for us to learn it, but at the same time, It takes a little bit to understand the difference between simple and compound. Hopefully that helps you be able to go through and practice your new skills. That's on your own, okay?